Okay, who wants to do some C programming? Today I am going to be looking at doing some maths with C. We're going to find the mean and also we are going to find the standard deviation. Now, I did study this at school many years ago, but I've forgotten how to work it out, and I've come across a book which tells you how to do it with some example code. So without relying on that too much, because if you just copy and paste it in, then you're not really going to take it all in. So what I did was I just looked at the functions. I have copied and pasted the functions, but I'm actually going to use them in my main, and I am going to load them up, test them, and see how they work. So without further ado, the book is called Learn C Programming. It's published by Packet, P-A-C-K-T. If you go on GitHub, you can download the code. You got all of the chapters. The example I'm looking at is actually inside chapter. What chapter is it? Chapter 11. So they're all in there, but rather than just open those files and run them, I'm gonna kind of do it a bit more manually than that. So what I've done is, just to speed up the video a bit, I've typed this so far: include stdio.h header file, include math. So you need to include math. When you compile it, you will need to compile it with, in fact, you could get away with just doing gcc stddev.c, that's the name of my source code, dash lowercase o, that's asking for the output file name, stddev. Then you have to do space and then dash lm. You need to link to the math header file. Then you do warnings or warnings error, and then these are all optional. So if I just, yeah, that'll give me an error because I've commented out too much. But you could just do that. So you could just get away with that and you'll get the same. So I'll show you that in a minute. So first thing I want to do is uncomment these function prototypes, or rather I'll uncomment the first one. So what this function is, it's returning a double. The function's called find mean. Mean, in more common parlance, is the average, and I'm supplying it a size. Size is the size of the array. There are ways to find out the size of array. If you use size of array divided by size of int, that will give you it. But if you already know it, then you can just pass it straight in. So this function asks for the size of the array, and then it actually asks for the array. So you pass in the array and you pass in the array size. Fairly standard with C. Unlike Python, where effectively an array is a list and you can just pass in the list, you don't need to pass in the size. So different to Python. So we'll just do the find mean first. So I'm going to uncomment int main, and I've actually typed all this in already because I thought I would actually check it works before I make a video. So int sz, so that's the size. I'm going to pass that into my function. So that's 9. I've got 9 elements in my array. My integer array is called ARR, and you can leave those square brackets blank there because after the equals sign, then you have curly braces with all the values of the elements in there. So hopefully 9 and 10 are fairly straightforward. So double is my variable which I'm going to set equal to the result of my function. So my function is called find mean. I'm going to pass into it the size of the array and the array itself. then print. So what print will do, it will print FM, and FM is the result of find mean. So if I run that, I've not shown you the function. So that's just the function prototype on line 4. This is the main where we run the function. The actual, so that's the prototype. Here's the actual function definition. Let's uncomment that. So double find mean, we pass in the size, pass in the array. What we say is sum, so we set a double variable called sum, and we start it at 0.0. And then as we iterate through every element of our array, so from 0 up to the size, which is 9. So from 0 to 9, we're going to go through and we're going to sum up the element, each element of the array, and add it to our running tally. So sum is like a current tally that you keep adding to as you pass through from, if you're visualizing it, from left to right or from up to down. Or double mean. So mean is a double. You can't use int because it could have decimal places in it. And then if you want to take the average, say the sum, you've got a sum of 2, 4, and 6. Add those together, that gives you 12, and then you divide it by the number of items, which is 3. So the average of 2, 4, and 6 divided by 3 is 4. Return mean. So if we run this now, we've got a prototype up here, our function definition down here, and then we've got the main here. So with those 3 things and this syntax, I'll just show you. If I left this out, just compile it the normal way. Well, it compiles. Why is that? I think we would get an error if we actually run it. Well, it compiles, but I would, best practice is to include, well, not even best practice, I would always do -lm if you're including the math library. These bits on the end are optional. It will still compile fine without those. Those are kind of warnings and everything. So there we go. So the mean of all of those numbers is 5.77. Right, okay, next. We want to do the standard deviation, which is possibly the more interesting part of this video. If you've done any C before or any programming, you probably understand how to work out the average. You just iterate through all the values, and then you add them to the tally, and then you divide the tally by the number of values. That's what that does. So, right, let's go up to here. Find standard deviation. What that's taking, again, is taking the same list, really. It's taking in the size, which will be 9. It's taking in the array, which we'll pass in that when we use it. So here, if we make some space, find mean, and then on here we'll do find standard, sorry about the typing, find standard deviation. So what we'll need to do is we'll say double equals SD. Sorry, no. Double SD equals find standard deviation. Pass in again the same size, the same array. So that's actually setting a variable to the result of our function. So that's our function. That's the name of the function. That's the size, which is getting from here, which is 9. The array, which is getting from here, which is all those values. and then could actually just copy that line. Yank, yank. P for paste. I'm using the Vim plugin, Vim extension for VS Code. I'm feeling quite adventurous, so right. Let's just insert there. And instead of, I copied and pasted that, sometimes it catches you out, but if you concentrate and you get away with it. So there we go. Need to do a new line there. Right, let's try and compile it. Always worth compiling as you're going along, otherwise you get so far and then you get errors like this. Undefined reference to so I've done the prototype up here. I've used the function in my main, but I've not actually shown the function and gone through all this. So this is the function, and if I uncomment this, we'll run through it. So what we'll do is that's the line which pretty much matches our prototype up here. When you do the prototype, you just need to remember to put on the semicolon on the end there, on end of line 5. So that line here on line 33 is the same. And then what we do is we say mean, and then we find the mean, because to work out the standard deviation, you need the mean. And variance is 0, and the sum is 0, just like the sum was 0 when we were finding the mean. So then variance we'll get to shortly, as you can see. Again, we loop through the array. Then what we do is we sum up power. So here, what we're doing is a to the I, sorry, AI minus the mean. So we know that the mean is 5.77. So for each value, we'll subtract 5.77 from the value, the current element. So when we're doing 1, it'll be actually be 1, that'll be 1, minus 5.77, so that'll be minus 4.77, and then we square it to the power, so to the power of 2, so it's effectively we're saying what's inside these brackets here, which would be minus 4.77, square it. So that should give us something like, I don't know, minus 22 or something. And then we divide, so as we keep going, we add up all the sums, and because we're squaring it, we end up with a positive value. Because we have a positive value, we can keep adding it to the tally. And then at the end, the variance is the sum of all of those divided by the size. So to work out the variance, we did these 3 lines. Then at the end, you take the variance and you take the square root of that variance. If you've studied networking protocols such as EIGRP, variance will be familiar to you. So and then at the end, just return the standard dev stdev. So back up here, these 3 lines will work now. So we find the standard deviation, which is basically using the mean, and then it's doing the current element minus the mean. You square it, you add them all up, and then at the end, you square root that. The reason why you square root it is because you squared it in the first place. And the reason why you squared it in the first place was because you wanted all the values to be positive. And basically variance is that way or that way, but you just cared about, all you're caring about is the magnitude. You don't care about the plus or the minus. Right, let's run it. Or compile it even. And then we run it. And there we go. Just tidy this up a bit as well. There we go. So mean, run that, compile that again. There we go. So mean equals 5.77, standard deviation equals 6.3. Yeah, one improvement to this code you could probably make is you could use size of, and then you could say you could get the size of the array, and then you could divide it by the size of int, and then that would tell you how many elements there are in it without actually having to know, because here we're having to specify how many elements there are, we're having to tell it. C doesn't know. C doesn't know it needs to be passed the size. So size and the array. So hopefully this has been interesting. If not, let me know why or what I could do to improve the video, or plural, future videos. So we've looked at mean, which is average, which we probably all remembered, but standard deviation, you subtract the mean from your element, square it, make a tally of them at the end, square root that big sum, and that gives you your standard deviation. What does standard deviation actually mean or prove? You'll see it a lot in sort of data science and so on. Standard. It's a measure of how far away you are from the center of the bell curve, if that makes sense. So that looks like quite a straightforward example. So it tells you how flat or steep your bell curve is. Or if it's skewed. So a bell curve doesn't have to be symmetrical. And beyond that, I'm starting to blag it, so I'm going to stop while I'm ahead, if indeed I am ahead. So thank you for watching. Hopefully you've seen how to compile using including the math library. Just like in Python, you would do import math. So we've just done that here. And you've seen that in C, we write a prototype, and then we write the main function after main. So main is here. This is where in Python, that would be more like int if dunder name equals main, then you'd actually run your functions there. So yeah, until the next time, thumbs up, please subscribe, it helps the algorithms. Comment, thumbs up, all that kind of stuff that everyone always nags you about. So until next time, thank you.